There are two kinds of energy, potential and kinetic. It takes work to wind this rubber band. The wound rubber band has potential energy. It has energy stored in it because of the winding. When the plane is released, the potential energy changes to kinetic energy, which is the energy of motion. The energy that it took to wind up the rubber band was stored as potential energy until the plane was released. Then, the stored energy changed to the energy of motion. These boys, girls, women, and men are competing in a ski jump competition. Before they race down the ski jump, they must climb a very steep and long set of stairs. It is hard work because they are not only lifting their own body weight, but they have to carry their skis as well. When they finally reach the top of the jump, they have gained a great deal of potential energy. Remember, potential energy is stored energy. When they go down the jump, the potential energy changes to kinetic energy, or the energy of motion. That energy allows the jumper to fly through the air and hopefully make a safe landing. There is so much potential energy that changes to kinetic energy that the skiers need a long landing area to slow down and stop. Think about someone on a trampoline. Can you identify when the person has the greatest amount of potential energy? There are two times when the potential energy is the greatest. One is at the height of the bounce. The other time is during the landing, when the trampoline material is stretched. When the person begins to bounce up, the stored or potential energy begins to change to kinetic energy. Enough energy to throw the person into the air. At the top of the bounce, the kinetic energy changes to potential. Then, the person begins to fall back towards the trampoline. The potential energy changes to kinetic. A roller coaster is a perfect example of potential energy changing to kinetic energy, and then back to potential energy, and back to kinetic energy, and so on. At the beginning of the ride, the roller coaster cars are pulled up the first and highest slope. A powerful motor is used to pull them along and lift them. This motor is powerful because it takes a lot of work to lift the cars so high. Once at the top of the track, the cars have gained a great deal of potential energy. Now, as the cars head down the first drop, the potential energy is changed to kinetic energy, and speed builds. At the bottom of the first drop, all the potential energy has changed to kinetic energy. The kinetic energy gained from this first drop is used to carry the cars up the next slope, where all the kinetic energy changes to potential energy once again. This continues over and over again until the end of the ride. At the end of the ride, the cars come rushing into the unloading area, where the brakes bring them to a screeching stop.
Now, let's look at some more examples. You may recognize this picture here. You can see there's a dam, and we have lots of dams around where we live. You know that we get some of our electric power from dams. And the way the dam is made is, just like in our area, there is a river, and what they decided to do was to block the river so that the river caused a flood, and in essence it forms a lake. And what happens is the water on one side of the dam is way higher than on the other side. The river continues on the opposite side, but we've got it blocked, so it just keeps backing up and backing up. Inside this wall, the dam, there's a turbine. Looks like a giant fan, and has a big wire going around a giant magnet. And when they want to make electricity, they just use the potential energy from that water being up high to move that turbine. So since it's up so high, it now has the potential to fall on the opposite side. So when they want to make electricity, they just open up those floodgates. Let me find my mouse here. They open up those floodgates, the water falls, and the energy from that fall turns the turbine and generates electricity. Now here's an aerial view. You can see in this dam it's a really big drop off, so we're going to get a lot of energy. One of the things you'll see a lot on TCAP is they'll show you a picture and they'll say, is this potential energy or is this an example of kinetic energy? What you'll need to do is look for motion. Now I know if we wanted to get technical, we could say, oh, the water behind the dam is probably moving. But think about what they most likely want you to notice. The water is up high, so it has potential energy because it's higher than the water on the opposite side. It can fall. These waterfalls here would be an example of kinetic energy, lots of motion. So let's look at some more examples. I don't know if you've ever been on one of these water slides. You know, it takes a lot of energy to get to the top of them. You have to climb a lot of stairs and usually wait in line forever. But the energy that you use to get up there is now stored and can take you down the slide. And the higher the slide is, the faster you'll go, the more energy you'll have. Now notice that this one we say is potential. They're at the top. But as they go down, we now say that this is kinetic. But think about it. She's not all the way to the bottom yet, is she? So yes, she has kinetic energy because she's moving, but she still has some potential because if she were able to stop herself, she would be able to continue to fall because she's up higher than she was before. She's not all the way back down. Now, swinging on a swing set's another good example of potential and kinetic changing back and forth in real life because usually that's what's going on. As you're swinging, on each side, you get really high on one side and then really high on the other side, and then you're moving back and forth between those 2 points. So you have potential, kinetic, 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 potential, and it just continues to transfer.